Hello,
Hi.
O'Shea and Matt J here today to talk to you about, I keep getting bored, video AF, which is electronic potential difference.
Sometimes known as PID, is burning urethral.
EPD, not PID, is electric potential difference, also known as voltage.
Symbolized with a V, also associated with V, PID.
The units for voltage, volts, are
Shocking.
scalar. They're a scalar quantity. The terms EPD and voltage, they're interchangeable. They're separate,
But equal. Not the same thing, separate.
But equal.
But equal.
They are a motivational factor. They're not telling you how many particles, they're not telling you the force of those particles, it's just a motivational factor for them. It's similar to like a child with a candy bar, you know? Like if you take that candy bar and you dangle it over his head, here little boy, you want this? And he's gonna be jumping in, he's gonna be swinging at it,
Or
he's gonna
a meth addict with a spoon.
want it, but it's not gonna tell you how he's gonna get it. Now the number that you're thinking about is current, and that's not what we're doing here. We're doing voltage. You're looking for current, you're in the wrong video. You can come back. Voltage, here's the eraser. I'm gonna have to cut this out. You know what, screw it. This is good material. Voltage can be shown in the equation V equals work over charge. It's almost like the gravitational potential, where if you have ground and you have something here and you're trying to lift it up to here, it requires work to lift the box, but there's charges involved, so that's how you get volts. And the higher you lift that box, the more potential energy it's going to have the force coming down on it. So you can use a parallel plate as an example. So what happens is, there's going to be,
Expletive.
you got your positive and you got your negative. So the positive, it's going to be repelled by the positive and be attracted towards the negative, and it's going to end up at the bottom. But to get the positive particle back up to the positive, where it is repelled, would require work.
Showed in this formula here. See, say you had 3 units of work, and your Q, that's the number of particles. Say you had 5 particles, that's 3/5. It's not a whole particle.
It's not a whole particle.
Not equal.
It's not one, but for every 5
There are 3.
charges, there's 3 works.
Representation and taxation. 3/5.
Not one.
Not one.
So in most cases, when we see energy, it's usually associated with joules, where 1 volt is the joules per coulombs. Is that how you say it?
Columbine.
We also use, when discussing energy, electron volts. Now, as you already know, 1 electron volt is 1.6 times 10 to the negative 19 joules. So, using that formula, 1 joule would have to equal 6.25 times 10 to the 18th electron volts. This number here is the number of particles in 1 column. It's the number of elementary charges in 1 column worth. Yes, 1 column's worth. All right. Now that we're done here, is the more you go up, you get higher. When you get higher, you really want to get back up higher again.
Yeah,
so you get lower.
Keep going
but
back.
Then you keep going higher. The higher you get, the higher you get is going to be the more energy, the more volts required.
These things right here, bolts.
Required to get you into that location. So the more you go up, the more work that is required. Thank you.
Thank you for watching.